Hi, everybody. Welcome to this session. We have heard a lot about how you can monetize your application, how you can promote your applications. And my focus is fundamentally going to be about how do you build it. The core theme is that if you're looking for one vendor who can help you build your application, help you promote it, and help you make money out of it, Google would easily be that one single vendor. I've been in the IT industry for roughly 15 years, more primarily focused on building large-scale infrastructures. And my background is in data science, and my published research work is focused on how do you take people, product, and place interactions and reason about them for insight as to how people behave in different environments. So to begin with, these are the trends that bring us here today, right? These are the trends why we have this conference. We know mobile games are exploding. We know social and connected games are becoming more and more popular out there. And one interesting trend is that Android users are actually playing a lot more games. I mean, their game sessions are typically 35% longer. They're having 65% more sessions. And from a purely ad perspective, there's 80% more revenue because primarily that's mostly an ad-driven kind of an environment. But the key here is, though, despite all these trends, one thing that remains elusive is how do you predict success of an application, right? And a follow-up to that, when your application is really, really successful, how do you avoid the technology tax? I'll give you a very simple example. I've been working with this game developer in Korea, and they were developing a game where you could fundamentally dress up a cartoon character in multiple different ways, and they were targeting at teenage girls. Over a short period of 2 weeks, that game went viral, and the average number of users shot up to something like 2 million users in a very, very short period of time. Now, how do you handle that kind of success? And secondly, how do you actually try and figure out what works and what doesn't? Those are pretty hard problems to solve, and the key here is that as you're building it out, you should be able to take advantage of platforms that help you start with that in mind and not worry about it once you reach scale, by which time it's already too late. So why is that important? Fundamentally, that's important because the half-life of a game is increasingly getting shorter and shorter. We get seeing half-lives of games of the order of 6 to 7 weeks, etc. In an average case, maybe about 3 to 5 months is the typical half-life of a game. Now, anything you can do to extend that out a little bit more is enormous amounts of opportunity to monetize and make money out of your game, right? And anything that you can do to handle this kind of spiky workloads in a very scalable, efficient manner without you having to own bulk of that work also is significantly important. Because what that does eventually is basically reduce the cost of experimentation for you. I mean, let's be honest, if all of us could figure out that Flappy Bird was going to be a huge hit, we'd have all programmed that from day one, right? That's the difficult bit. You don't know, you need to experiment with, and having a platform that scales automatically takes care of the technology tax that comes when you're successful, and at the same time allows you to create more engaging experiences that extend the user's life, makes a huge amount of difference. And why is, as in that part of the journey, we find that being connected and generating connected games simply seem to be the games of the future, primarily because it engages social aspects of users. It allows you to basically reduce piracy significantly, and at the same time, it affords opportunities for measurement and understanding of user behavior in ways you couldn't do before. And for all of those reasons, having games connected to the cloud, serving data from the cloud, analyzing the data in the cloud, and then customizing that user experience on that app game makes a significant amount of difference. Now, where does Google fit into all this? We are easily the only platform out there which allows you to look at the entire life cycle of that game or application that you're building, right from the moment of when you conceptualize and build it to how you want to acquire new customers to that particular application that you're building, how you make money out of it, and how do you retain and create engaging user experiences out of it. Now, across that whole life cycle of that particular game, Google is the only vendor which has solutions across that entire life cycle. And the nice part is all of these different solutions work with each other, and they're co-hosted in that same infrastructure that powers Google. This is one screen image of one small part of one data center that Google runs, right? And each of those lights you see in there, right over there, where we see laser right there. One of those represents a single blade, right? Now just think about it, how many of those go down there, and then multiply it across X and Y, and look at the size of servers that Google actually delivers. On the platform side of things, we have had customers spin up 80,000 cores, which sounds like a lot, but in Google scale, it's not really a whole lot of machines for us. So this is what powers Google, right? And what we're exposing as the Google Cloud Platform on which you can build your games is that going to run on that same kind of infrastructure, right? Essentially what powers Google and makes Google successful is now being exposed as services that you could take advantage to build your own applications in your games. And when we expose that, we expose those services in 3 different buckets. The first one is the compute bucket. The second one is the storage bucket. And the third one is about higher level services that we provide, particularly around the analytics and the measurement side of things. So on the compute bucket, we have 2 different offerings. One is what we call as App Engine, which is heavily popular, particularly among mobile game developers, particularly those who are developing turn-by-turn based games, casual games, and things like that. They love the flexibility of the App Engine platform, and that's a platform as a service offering. What that means is that Google provides you an SDK, which encapsulates all of the best practices, essentially encapsulate all the best practices Google has in building 3-tier web applications. You take that and you build your application in one of 4 different languages, the application backend in 4 languages, Python, PHP, Java, or Go, and then we take care of everything else for you. All you have to do is to configure a key parameter, which is that what is the end user's perceived SLA? In other words, how long should a request wait before it is served? And once you configure that parameter, since it's running on our platform, we know the inbound request rate. We know both the rate and the velocity of that, right? So using those, we can basically scale up, scale down, all of it in a very transparent way without you having to do anything. The second one is our compute engine, which is our infrastructure as a service offering. So basically, you get virtual machines in the cloud, KVM, Linux instances, and Windows instances. You can spin them up any way, shape, or form you want, but you take on a little bit more of the responsibility of actually putting that infrastructure together. But again, you have the same features there as well, but you scale at a different level. The second bucket is all about storage. So in other words, storing and serving data in multiple different ways. So those could be object-based storage, which is our cloud storage, which lets you store unlimited number of objects up to 4 terabytes an object. We have Cloud SQL, which is basically a relational data store. Cloud Data Store is basically a NoSQL storage. And then finally, we have persistent disk, which is actually a block storage. Now, all of these things are the same things that power Google. For example, the cloud storage infrastructure is pretty much the same thing that powers YouTube, right? So the cloud data store is the same NoSQL storage that powers App Engine and handles something of the order of 7 trillion I/O operations every single month. It's that scale offered to you as a service, and you can just build without worrying about how things actually scale and grow. The last bucket is about all of these higher level services that we provide. The first one is BigQuery. So we have heard a lot about what analytics means and what that potentially means to you as developers and managers of games and game companies. I have worked with a fair number of game developers across the region, and the first question I ask them is like, okay, you have this wonderful portfolio. Now, how do you measure how a user engages with you on the game? How do you know which particular action of a user is interesting or relevant? Usually, there is a deadpan silence because they most of the time have tremendous amount of difficulty dealing with the scale of that problem. One particular game developer that I'm working with right now is generating 9 billion events within a 20-day cycle. And they want to be able to analyze all of that information in the aggregate to say, how did a particular addition of a new item change gameplay and stuff like that. And classically, that's been a difficult one to build your own infrastructure for. What Google does is basically take the same stuff that powers our analytic infrastructure. In other words, in Google, if you asked a question like, how did this AdWord perform in this geography between this time frame, that's a couple of billion rows of data we have to munch through to give you that answer. We've taken that same thing, put it out there, so that you can bring your data in CSV or JSON, which is useful because a lot of apps servers generate a lot of log data in JSON. Bring that in, and then you can just write your queries in plain old SQL, and then analyze and slice your data in any way, shape, or form. So I'm working with that with one particular game publisher, analyzing their entire portfolio of about 100-odd games, and looking at 9 billion rows of data to understand where are users playing their games. And they are now considering using additional features of the platform, like looking at the sniffing for 3 different Wi-Fi IDs in the proximity. So using that and using our Maps API to figure out where is the geolocation in an approximate way. So you can start asking questions like, is this person playing the game more at commute? Are they playing it at lunchtime, and where? So fundamentally, still be able to ask those questions about how your product, how your people, and how places interact, and analyze that across both time and space. So what does that mean for you? Essentially, you forget about scalability. Scalability is our headache. We take care of that. It's easy to use. The key here is that you focus on those aspects which add value to your game, right? Everything else, the 90% of the work that you have to do to maintain that infrastructure, scale it, grow it, etc., that's Google's problem, because you're just going to rely on Google's ability to provide those services for you to make that happen, right? I won't get into monetization because that's being dealt with in significant amount of detail, right? So when you look at that, let's say what are all the classic kind of issues that come about when you go about looking at these scenarios, and let's look at what we can do for each of those. The first one is obviously everybody here invariably runs their game in some kind of a cloud infrastructure, right? Is there anybody who's running their game on an on-premise infrastructure here? No? Anybody using a cloud-based backend to support your game? No? Anybody writing games? No, kidding. I'm sure you are. You're a little shy, I imagine. But there is usually a requirement to make a distinction between whether you want to go platform as a service or infrastructure as a service. In Google, we provide you both. In fact, we sort of made that false dichotomy whether you go platform or infrastructure, taken that away completely. In other words, you could have a platform as a service, which is our app engine, write an application in there, and parts of that application can actually be spun on a compute engine infrastructure, and maybe you want to run some very complex code in there which needs to be running in its own VM, etc. And you can blend it all together and make it look like one application. And that is something Google can do very comfortably for you. And we have customers who actually do use the platform in a significant amount of way. For example, everybody knows who Rovio is. So Rovio's web-based Angry Birds is all running on top of App Engine. And what that affords them, because Rovio's games, particularly the Angry Birds versions of those, they just get a huge, enormous amount of load the minute they launch, because a lot of people are playing them and experimenting with them and so on. And what they get with App Engine is basically an ability to reach that wide number of users without having to worry about how do you scale to make that happen. How many of you have heard of Snapchat? 1%, 2%. They're basically in the field of ephemeral messaging. In other words, you take a picture, you send it out, and the message that's sent out to your network, social network, exists for a short period of time and then disappears. And you get to decide how long that message is persisted, right? Snapchat's entire infrastructure is running on top of the Google Cloud, right? So they started out on App Engine, and now they're they're running on top of Compute Engine as well, and they're using the whole platform to actually make that happen. And they deliver anywhere between 350 plus million photos using the Google platform. And they've been extremely successful because they have been focused primarily on what adds features, what new features they can experiment with and deliver to their customers, as opposed to worrying about how infrastructure really works. The second one is maybe you already have an application, but out of that application, you need to distribute a huge amount of data and content, etc. Right? This is a very classic problem that you will encounter, whether that game be a game that's on an Xbox or anywhere else. You still want to solve that distribution problem of getting that large media files out there. And that's where the Google Cloud Storage really works very, very well. It basically runs on top of Google's Fiber, so it automatically take advantage of Google's global presence. And whatever you put in there, and you can set any kind of security model you want on there, it can be made available in a global fashion. And that makes a huge amount of difference. In fact, Ubisoft does this using the Google Cloud Storage. So they have a huge amount of data that they want to distribute for a game that they design, a console game that's called From Dust. And all of that data is actually being served out of Google Cloud Storage, right? So none of these features and products that I've described to you, do you have to consume them all at one go. You can take different parts of it and use them as the case may be and how it might solve your particular problem. You have this other problem that a lot of our customers run into, is that they want to target multiple different environments. They want to develop the same backend, but they want to be able to deliver their application on an iOS, an Android, on the web, etc. Now, the key problem here is being able to write client code for each of those targets and also be able to deliver data, handle the security on top of that, and that's a lot of work. So that's where our higher level service, which is Google Cloud Endpoints, makes that a real easy thing to do, because what you do is to write your server code on App Engine once, then you annotate your code, and we take all of those annotations that you put in, and automatically we generate a library for client library for Android, a client library for JavaScript, and a client library for iOS. You just include those libraries in your application, and then you can basically focus on just the user experience, and all the data marshalling back and forth between the server and the client, it's automatically taken care of for you, right? And then we get into this idea, okay, I've built that game, now I want to go ahead and figure out how the user is actually engaging with that game. And you have many different offerings that actually help you with that. One of the offerings we dealt with in an earlier session was all around Google Analytics and how that helps you make that happen. Equally, you could take the data that comes out of Google Analytics and put that into a tool that I just described, which is BigQuery, and then go ahead and analyze enormous amounts of event log data on how actually end users are engaging with your application. So when I was working with most of my game developers, as they're trying to develop games, I always ask them to think about log data in 4 different aspects, which is who's the subject, what's the action, which is a verb, and what is the target for that action, and a timestamp, right? So if you fundamentally have your log data segregated in that way, analyzing things becomes much, much easier. You can then create different kinds of aggregations out of that basic structure, which allows you to do high quality analysis. One common aggregation is sessions, one common aggregation is transactions, and one common aggregation would be around different spots and places in the game, and etc. So you can create different aggregations if you have that kind of a structure about who's that unique individual, what is the action or the verb that they're performing, what is the target of that action, where they're performing that, and when they're performing that. And if you make sure that your log is segmented in that way, going back and analyzing it and creating aggregations out of it is much, much simpler. So that's exactly what Claratix does. Claratix is a provider who's using Google's tools, particularly BigQuery, and they provide social and social game analysis on top of that. So all of their trend analysis, etc., all runs on top of Google's BigQuery. So you can look at, for example, in this example here, you look at a downward trend in average engagement of the user, then you can start to segment your user across different segments, and then you can do cohort analysis around when that customers were acquired and see how things have been changing and so on, and make different actions to actually recommend to those users. We have a whole range of features that allow you to do. We also have something called a prediction API, which is fundamentally a machine learning API exposed as a service. You can marry that with this and then figure out what kind of offers might be interesting for that particular user, or to re-engage that user, what would be the right time to send that re-engagement email, etc. So those kind of analysis that you want to do is well served by using BigQuery and the Google platform. Yet another customer of ours, Songpop. How many of you have heard of Songpop? Yeah, I used to play it quite regularly at one point in time. So until my wife decided that was not too healthy. So basically, Songpop uses Google's cloud storage. It's a really fun game. It's very addictive and very fun. So basically, there's a snippet of music that plays, and you're competing with other friends of yours to figure out what that snippet of, which song that snippet of music is all about, right? And that, again, that entire thing is being served out of Google Cloud, and they use a combination of both Google Cloud storage and other services within the platform to basically cater to roughly 60 million users across the world. Now, there's a key theme here, recurring theme, right? The key recurring theme is that you want to be able to experiment, and we make those experimentations really easy. You want to be able to do that in a way and shape such that when that experiment becomes successful, you don't get penalized with the technology tax to be able to cater for that additional load. Again, Google takes care of that part of the equation for you as well. So if you look at architectural design patterns that one can put, taking all these different components together, there are two key ones that arise. One would be around the dedicated server gaming solution. So you have basically game servers. These are game servers which require a huge amount of computation, and those could be running inside Google's compute engine. You have App Engine, which is handling pretty much the front-end tasks and the tasks of matching game servers to a particular client and such. And you have all of that data that's coming out of both App Engine and coming out of the individual game servers itself being put into Google's cloud storage, so that you can store huge amounts of transactional log data, and that data could be you can use to create higher level aggregations, which then can be analyzed by BigQuery and such. So this is one design pattern and one way of building a dedicated gaming server solution, which is targeted at game backends, which require a huge amount of custom code that's running inside virtual machines, right? And the front end of all of this is basically running inside App Engine, which does things like processing, server matching, virtual machine orchestration, and such. If you take the mobile games, you could do a similar solution, but now the nature and the roles played by the different components change somewhat. Because here, App Engine starts to take a much bigger front end, because it's handling all of the different clients through cloud endpoints. You can use cloud messaging to push out outbound messaging to Androids. You can use our Sockets API to send iOS notifications and such. And with cloud endpoints, you're able to target the iOS client, you're able to target the Android client, and if need be, a web client as well. And here we use the compute engine primarily to handle back-end processing tasks which are not fundamentally user interactive tasks, but tasks which are fundamentally batch-oriented operations. For example, let's say the user uploads an image and one needs to perform some processing on that image prior to that image being actually put in part of the user's bucket to be able to be seen, etc. Those kind of batch processing operations would run very nicely within the compute engine infrastructure. Again, once again, all of these push out log data into Google's cloud storage, which we can use Google BigQuery to go ahead and analyze it. And all of the game state data we store inside data store which is basically our NoSQL storage, which can handle huge amounts of transactions. So depending on the nature of the game, you could take the same components from Google Cloud Platform and snap them together in different ways to produce different architectures. There are some other solutions we provide, particularly in terms of being able to promote your game and also in being able to monetize your game and such. But the one key thing I would emphasize here is all of these APIs run on the same infrastructure. In other words, if you're hosting a game on Google and you're taking advantage of some of the other Google APIs, they all exist together. So there are a couple of advantages for that. One, the latency to those services is extremely, extremely short, right? Because they're all in the same infrastructure. Second, there is no egress that you really need to pay for if you ran it somewhere else, right? So if you're running it on Google Cloud, the egress is basically free because it's all internal Google traffic. So that's a quick overview of what we provide as services, how you could snap these things together to build different kinds of games. Now you may say, well, how do I get started, right? Well, you're in luck, right? What you could do now is to go to cloud.google.com/starterpack, and there is a form in there. And if you fill up that form and use that code, BIN, when you fill up that form, we'll give you $500 of free credits to go out and try and play with it and see how that platform works out for you, right? So the easiest way for all the stuff that I've just described with more design patterns, more videos, etc., which talk about how to build these things, would be cloud.google.com. That's the central resource. And if you have a Gmail account, just hit that Try It Now button. Automatically, you can spin up a project. And if you go to cloud.google.com/starterpack, you have a form where if you enter that code, you will get about $500 of free credits for you to go ahead and test and experiment with the platform as well. So I really encourage all of you to go ahead and give that a shot, play with the platform, and see what works for you. And the resources are all there in cloud.google.com. So, in conclusion, we have the infrastructure that can take care of your back-end needs very effortlessly and very easily. So that you focus on your game, we focus on everything else to make that infrastructure scale and be successful. So you focus on the 20% of the tasks that actually add value, the 80% of tasks that don't really add value to your game but are required to make it run. That's Google's problem. You can get started pretty easily and grow really fast. There is no tax if your game goes viral or gets really successful, right? Because it's all as a pay-as-you-go model. So we only charge you for resources that you actually consume. So if your game gets really popular, we obviously will have to incur further traffic and resources to support that, but it comes out of additional revenue that you bring in out of your game, right? So that makes it an extremely easy proposition commercially for you to go out and experiment with it. So in conclusion, what I would say is out there to find out what games work and what aspects work require a significant amount of experimentation. And when that experiment actually is successful, you often end up with a technology tax because you've got to scale it up. What Google does is we make that problem very, very simple for you because we take care of all of the hard parts around hosting and scaling that infrastructure automatically for you so that you focus on what makes the most sense, building a successful game. So that's about all I had to present for today. So if there are any questions, happy to take them. If not, I'll hand them back to Vinny. Thank you.